Well, we're back at it again. I thought I'd go over a couple things real quick. So let's just get into this. Tell me that don't look cool. I'm told this is the first generation of the the Cleatrack styled. Started in '36. Brass tag, I guess, is extremely rare. So that's something we got to hold on to. That's freaking cool. But I thought I wanted to go over a couple things. It's got to be on everybody's mind. And the first thing is, why would you want to try to fix this piece of junk? Well, there's several reasons. One, probably the number one thing is the cool factor. How cool is that? So apparently, Hercules would, whoever their customer was, they'd cast that into their manifolds for them. The next idea is they say these things are extremely rare. If you can even find them, they're nearly impossible to find. But if you can find them, they're just way too expensive to try to buy. But lastly, look at the challenge in it. How fun is that? Trying to come up with a way to fix this mess. So anyway, our next step is we got to seal this hole up in here. You can see my leftover braze where I tried that before. It didn't work. But anyway, I run to the Lowe's and I got this elbow. We'll see if we can cut out what we need. This is pretty close on the right shape. Set her in there and braze that all together. This is malleable iron, so I figure braze is probably going to be the best option for it. So we've got to do a little clean up on this and get it ready. I'll get you on the tripod and we'll start doing something out here. Well, we're back at it. So I used our little plethora of grinders here. Got in here and cleaned this up. I need to come in here and build this up with weld. I don't know if you can see this. See how this has a nice ledge here? This needs to get built up to match that, so when the nut tightens down, it's got a good flat surface on all of that. But we'll use good old Eastwood over here. And because I'm the most like ADD person of ever, who thinks we need to finish this gearbox? It's got a bunch of other junk laid on top of it. I don't think it's ever made it into a video. But I made all those gears. We used the CAD CAM software to design this gearbox for a lathe. Of course, I got all kinds of junk everywhere. Anyways, yeah, I'm the most ADD person of ever. Anyway, let me get you on the tripod. We'll see if we can kind of build this up a little bit. Alright, we got her built up a little bit. We'll have to go in there probably with the grinder and clean it up just a tad. But really the important thing is that it's built up and I can take it over to the mill it off flat and make it match the other side everywhere it needs to. Well, I went ahead and bandsawed this out. We're starting to get her to fit. Need to do some more sanding and trimming. You guys even see that? I brought you back after an untold amount of fiddling and working and fiddling and working and fiddling. We finally have this. It may not be perfect, but it's pretty close. So I'm going to get this exactly where I want it, and we'll start brazing this thing on here. Alright, it's in position, and let's see if we can start working this thing in. Just like before, start getting some heat into this. I probably won't get all of this recorded for you. It's just going to take way too long. It's going to get way too boring. Then I'm going to have to move it around all kinds of different positions. Because the setup time is just going to be way too long. I'll try to get to the important part. So you can see we're starting to get there with it. And I think I'm going to have to reposition already. I think what we'll do is go ahead and just stop recording now, and I'll just get this done and bring it back, and you can see the final back in handheld so I can get you real close. Well, as of right now, it don't look real pretty. We'll get it cleaned up. Try and get you all the angles here. Yeah, it needs lots of cleanup work. Right now it's pretty hot, so we're just going to have to let it cool down. We can come back and we'll clean it up and get her in the mill. Get the sealing surface flat. So I decided I'd take this into work today and sandblast it. And then I threw a coat of high temperature paint on it. I didn't want it to flash rust or anything. So anyways, I think our next thing to do is grind this mess down and make it look presentable. So I'll get you on the tripod and start grinding on it. I don't think we'll video all the grinding, but I'll get a little bit of it on here for you. Well, after quite a bit of grinding, I think we have something that'll be presentable. Couldn't get down in here as good as I would have liked to, but I think we're going to live with it. Still need to come in here and clean this up a little bit with an end mill, so this is flat across here. And then we need to get this back in the mill and come across this and make it all good and true, flat. So that'll be the next step. But I think it's looking pretty good so far. So we're back at the mill now. I got her clamped in there. And try to keep an eye on this needle that you can't see very well because, well, this is a working shop and stuff gets painted in here, including the indicator. Anyway, keep an eye on this needle. I'm going to move towards us. We're within about 1,000th there. Of course, the backlash messes with it a little bit. Definitely below 2,000ths. I've gone this direction as well, but it's futile to show you that on here. I can tell you right in the middle there is a bit of a dip. Maybe 15 thousandths or so. So all that's going to get cleaned up. And let's see, I'll get a tool in here and we'll start cutting. Well, before we start cutting, I think I'll kick in here and give us a little bit of machinist math lesson for the day. This is probably beyond, say, Rick Bork level or Kirky level. Yeah, I'm just yanking your chain, guys. But yeah, stuff's boring, but it is important to know so you don't burn up your cutters. So anyway, this here's diameter of our cutter is 3/4 of an inch. Multiply that by pi, or 3.1416. And this will give us the circumference of the cutter in inches, 2.3562. Now we take the circumference of the cutter and divide it by 12 to give us the amount of feet. That's 0.19635 feet in a circle around the cutter. All right, we'll take that number, 0.19635 times 660. And we get this off our chart here of spindle speeds, which is where I have it set. You can see the belt up in there. 660. 660 gives us 129 and a half surface feet per minute. We use that number constantly. So 129 surface feet a minute's probably a little faster than what I want to run. But my next option was 325, and that's slower than what I want to run. So this is pretty much my best option, I think. Some of you might disagree, but we'll see about taking it kind of easy on this, and I'll get you up on the tripod and we'll start cutting. Here we go. Contact. Now, like usual, I'll probably just make a little pass for you guys to see the process, but I'm not going to record all of it. Let's see. Let me go handheld for a second. I don't know if you picked up on it or not, but when I started out over here, where this patch is, the steel got really hard. So I was kind of struggling with it. Probably hit this with a file just real fast for any ridges or high spots that got left behind that shouldn't be there. All things considered, that's pretty good repair. So I think our next step is going to be coming in here and cleaning this hole out, because a stud needs to go through that. Which, that'll be easy. I'll just grab a 1/2 inch end mill and plunge through there. There's not much material in there. Hopefully it goes well. I'll bring it back. Alright, let's pop a hole in here and see how it goes. There it is. Yeah, that's pretty successful so far. So we used an end mill instead of a drill for this, because the end mill is not going to care what kind of stuff's in there. It's not going to be like a drill and try to go off on an angle. We'll just go straight down with it. It doesn't care. Well, we're back and we're ready to flatten off this here, face off, flatten off, whatever, this little nub here, so when the nut tightens up on the stud, it puts even pressure on both sides of this cut. Let's get in here pretty close. I think we can call that a pretty successful repair. Try to keep you in the middle of the shot. Got her hanging up. So, got this high heat. Resist heat up to 1200 degrees. Rust-Oleum. So, we're going to see if I can hold you guys still enough while I paint, so you can get a good watch at that. I already shook this up quite a bit earlier. Alright, there you guys go. That's one repair in the books. You know, as an afterthought, we could have made this match a little bit better if I'd have come in here with the needle scaler and gone over that and kind of dimpled it up to match, but I think that's just good enough right there. I don't think we would want to go any more. Quit messing with it before I screw it up, right? I mean, how cool is that? Clee track. You don't see many of them. I hope you guys like that episode of Shop Time with Dave. So I think our next adventure is going to be seeing if we can fix this camshaft. Yeah, that was brilliant. I got an idea how we can do this. I think it's going to be a lot cheaper than trying to find us another camshaft for Hercules OOC. So if you like this kind of stuff, making something from nothing, trying to save $1 where we can, come back and see us with Shop Time with Dave.